Assalamu alaikum. As you can see that our first task is to blink LED using Arduino IDE. So in the following step, it is told us to install the latest version of the Arduino IDE, which I already did in my computer. So in step 2, they are telling us the procedure that we will have to follow in order to install the Arduino IDE up to step 4. Well, I actually already installed Arduino IDE. As you can see, there is an icon on my desktop, so I will just open it. So as you can see, it's already open. So now what we have to do is to connect the Arduino with our laptop, which I already did. So in order to check that if our Arduino is connected or not, we will have to check through which port the Arduino is connected with our laptop. So in order to do that, we will go to the device manager. Okay, we will open it, and then over here we will press P and it will directly go to the port. As you can see over here, port COM3 is connected, so it means that through COM3 my Arduino is connected with my laptop. So now I will go to the manual back over here. Now we will read the step 8. In step 8, it is told us to click on tools, and then over there you have to select the port to which your Arduino is connected to make sure you are using the Arduino, so there will be no trouble when you will be uploading your code on the Arduino. As you can see that it's already selected on my laptop. So now we will go to files, then there are some example codes over there, and from there on basic we will select a blink code on the Arduino. So over here in files, example, basic, there is a blink code. As I click on it, the blink code will open. As you can see, it is already an example which is already saved in this Arduino software. So first I will save it in my laptop. So I will press save as in this PC, local disk F, software, Arduino, and is open save. As you can see, it's already saved in it. So now we will verify the program to check if there is any bug or error in it. So let's verify our program. As you can see over here, it's verifying our program to check if there is any bug or not. As you can see, it's done compiling, so that means that our program is executable. It can run our Arduino. So now we have to generate the hex file of this program. So in order to generate the hex file of this program, we just go to the sketch, and there is export compiled binary. So by clicking that, the hex file of this program is generated where I saved my program. As you can see, I saved my program in F software Arduino Anis. So over here you can see that this is the hex file that is generated. Okay, this hex file is actually used when we are doing some simulations on the Proteus.
So as you can see over here, our light is blinking on Arduino.
So now we will be performing our lab task 2, which is to blink LED using Atmel Studio. So as you can see in step 1, it is told us to install the and download the software. I have already installed it, so let's just open it. So up to step 10, these are the installation and downloading steps, and in step 11 I do know that my COM port is 3, as I showed you earlier while performing the lab task 1 while using Arduino IDE. So now we will go to the step 12, which is to go to the tools. In external tools we will create a file named send to the Arduino UNO, and we will select this path. Actually this path may vary for everyone who has downloaded the software in different local disk instead of C. So I have installed all of my software in local disk F, so I will just browse it all by myself, and we have to select this .exe file which name is avia dude. So just let's get started. We will go to the tools, external tools, add in title. We will just copy the same thing, send to the Arduino. Now make sure that you don't copy the quotations and just paste it. So now let me browse the path for avr2.exe. It is in F softwares, Arduino, hardware, tools, avr, pin, and over here it's avr2. So we will just open it. Now in argument we will just copy this path. Make sure you don't copy the quotations. So after copying it, just paste it over here. So as you know, I didn't install the software in local disk F. In C I have installed in F, so I will write F over here, and instead of program files I will just write softwares, because that's where I have installed my all softwares. Now I will just copy this. Make sure to change your COM port name, because for me it's 2, maybe for you it might be 6. So be careful, otherwise you will not be able to upload your code to the Arduino. So instead of 6 I write it not just, then click on apply and OK. Now after doing these steps, we will just create a new project in the assembler using AVR assembler project using 80 mega 328p, because the microprocessor used on the Arduino Uno is 80 mega 328p. That's why we will select it. But if you are using Arduino Mega, then it may change for you, which is 80 mega 256p. I guess maybe look on internet for it. So let's go to 328p. Okay, now it's creating the assembler application. Now once it's created, all we do is to just copy this code, assembly code, and we will paste it. Okay, and just paste the code over here. Okay, so after pasting the code, we will just go to the build and click on the build solution. Build solution over here, you can see it's open. Now after doing that, we will debug our code, which is go to the debug and start debugging, or you can basically press alt F5. So I will just start debugging as shown in the manual. Now you know that there is a tool we have connected it, so it's actually a simulator debugger program. We will select it and now just go to the main ESP and start debugging it. It will debug. So now while debugging, we will go to debug and debug step into and open the registers which are already open and the IO ports. So we will just go and debug step into. Now it will be debugging the line of the code one by one. First it will debug this line, then it will debug this second line, and then the third, fourth, and so on. And now we will be able to see our input output changes that are happening in the registers over here. So let's click F11. So as you can see, it's moving. Now as you can see over here, we can see that these are reds. That means there is no data in it. Over here it's a bit 5, these are bit 6, and so on. If I keep on pressing step into, it keeps on changing. So our program is debugged, all of it. Now after that, what we have to do is to click on the main ESP tools and send it to Arduino. So now we will send this code to the Arduino by going to the tools and click on the send to the Arduino, the thing we created, the path. Now after clicking on it, our code is sent to the Arduino Uno, and now what we have to do is to click on the main ESP window and open the containing folder over which it is. Now we will go into the debug over here. This is the hex file of our code. Okay, it will be used in the Proteus while uploading the code. So this hex file is very important, so make sure that you do remember where your hex file of the code is. So I will just cross it now. Now after that, what we have to do is to create a new project, and we will run the code for the blinking of the LED in the C language. Okay, so for that we will have to select GCCX executable project. Okay, so let's cross it first. Now stop debugging, file, new project in the C++ GCC executable project. Now press OK. Again select 328 bit because I'm using Arduino Uno, that's why I'm selecting this microprocessor. Now after it is created, now what I have to do is to just copy this code and run it, debug it on the Atmel Studio. So I will just paste it over here, copy it to. Now I have pasted it. Since one bracket is missing over here, I will just put it the bracket of the main program, which is telling us that our program is ending over here. So now what I will do is to debug it and to check if there is any error in it or not. So let's start debugging. As you can see, now I have to select the simulator again. It is necessary. Now I will go to the main.c where my program is and debug it. Now let's debug into step into and let's see what are the changes happening over here. Okay, now I will press F11. As you can see, as I press F11, it is debugging the next statement, and the changing that is happening inside the register we can see over here in the bits. Okay, so now we will move towards our lab task 3. So now we will be doing our lab task 3, which is Proteus simulations. For it we will have to download the Arduino library first and then paste it in the Proteus library. I have already downloaded and pasted it, so we will just get started by creating the new project from the step 2, and over there we will select on the from development board and Arduino 328, and then we will finish. So let's open the Proteus. As you know, we are opening Proteus. Now we will click on the new project. I will name this project with my roll number and following my name, which is enemies. So we will click on for development board. As you know, I'm using Arduino 328B. So we will click on it and then we will finish it. So you know, our Arduino is this circuit is created on the Proteus. Now what we have to do is actually upload the hex file in the Arduino over here. It is the hex file that we generated while using the Arduino IE when we were doing the blink code. Okay, so I do know where is the hex file, so I will just browse it by myself. Over here in this program file folder, here you have to upload the hex file. So it is in local disk F, 5th semester in micro lab simulations, Arduino simulation. This is the hex file I was talking about, so I will just click open and press OK. Now I will just simulate it and we will check if our light is blinking or not. So after some time it will blink. So if it's blinking, it means our code is working. As you can see, it's blinking, so that means that our simulation is working and we have performed the lab task correctly. So now I will just stop recording the video because I have done my all the objectives. So today I will be telling you how to perform few tasks on Atmel Studio. So let me open our first task, which was to store 13 in register 16 in binary and display it on any port, and then at 25 in it, okay, we have to show its simulation on Atmel Studio using these commands. So let me open my Atmel. It may take some time. So now as you can see over here, this is the code of task 1, which is what to store 30 in the register 16 and then add 25 in it in the binary. So as you can see over here, I have used the load directory command LDI, which is used to load a value in the register. So it will actually stores the 30 in the register 16. This is the binary value of the 30. Okay, and now this is for initializing the register 17, in which we will just store 25 because we have to add 25 in the register 16. So that's why we have to store first 25 in some other register. So now I am declaring the output B as an output port where I will be displaying the results of my register 16. So now I am adding the two register 16 whose value inside it is 30 and register 17 in which the 25 is stored. Now this command will add both of the register. Now 30 plus 25 is equal to 55, that will be stored in the register 60 now. And when I did the output on port C, so it will display that the in register 16 there is now 55 instead of 30. Now then I am clearing the register 16. So let me debug it and show you how it works. Start debugging, and now it's debugging. Let's open the windows of the input output, so where you can see on port B and port C the results. Now I will just press this command, which will press this and it will execute command one by one. So first of all, it initializes the register 16 and it will store the value 30 in it. As you can see, the hexa of the 30 is this. Now after next time in the register 17, the 25 is stored. As you can see in register 17, 25 is being stored. Now what will happen on the output port B over here, the value of the register 16 will be displayed. As you can see over here, the value is being displaying. Now the addition will happen. Now the 25 will be added in the register 16. Now that output will be declared on the port C over here. As you can see, as I press the next command, executed, and now as you can see on the register 16, first it was 0x3e, which means the 30 was stored in it. Now it's 0x37, which is the hexa of the 55 hexadecimal system. In values are being stored in hexadecimal system. And now after when I will execute this command by pressing this, the register 16 will be cleared. As you can see, the register 16 is cleared, it became 00. So that was our lab task 1. So now I will move towards our lab task 2, which is to take input from one port and display it on the another port. So let me show you the Atmel simulation of it first. As you can see, this is my task 2 and here is the code. LDI is used to initialize the value inside the register. Out is used to show the result on any port that we want to declare as an output, and in is used to basically put the value inside the register from any pin. Okay, it will be reading data from that pin and will be storing its value to the register 20. Okay, now subtraction function is used to subtract it, and output is used to display an output. So I will just start debugging it. Stop debugging. Now for that I have to open my lab task 2 instead of lab task 1. have to close it first. Now the task 2 is opening. Now as you can see, the task 2 is open over here. So now I will explain you the code of the lab task 2 already. So now I will just debug it, and I will just open the window got open. Now I have to select port B and port C, because over there I'm just displaying my output. So I will just select port C and port B. Now again I will execute the lines of the program one by one by clicking this step into. As you can see in register 20, the value or hexa value of the is stored, which I have assigned to the register 20. And now after in R21, the next value will be 0x17, which is the 25 value in the decimal system. So now after that you will see the output on the DDRP, as you can see over there, and now you will see the output on the DDRC. And now the input it will be taken from the pin C, okay, the register from the register 20, and now it will be subtracting both register and displaying the output on the port B R20. As you can see over here on port B, it has displayed the output, and this was the R20 input which was being taken from the port C. Similarly, now the code has finished. Now I will just open the lab task 3 and we'll show you the simulation of Atmel Studio first, and then we will move towards the Proteus. Display the charging sequence of the using these commands. As you can see, these are the commands we should use: clear, CBI, SBI, skip bit, or clear bit if carry is not equal to 0 or 0, and initialization. So I will just open my lab 3 task. Task 3, I will just open its main file because it will be opened over here. Now I will just copy it first, cross it and paste it over here. Now let me explain you the code. Over here we are just initializing the value to the register 16 and register 18. As you can see in the comments, storing the value 00 and 00, it is FF in the R18. Now out DDRP, now I'm declaring port D as an output port, okay, and now I am setting a bit 1 on the pin 0 of the port D, okay. Now after that, what's gonna happen is that LDI R19, 0x25 is being stored in the register 19, and after that I have made a loop over here, LOP1, which will keep on repeating again and again until the value of the register 19 becomes 0, and it will be displaying the output on the port 16, the value of the R6 register 16, and will be adding register 16 and 18. And after that over here it will check that if or 0 on the status register, if or 0 is 1, then it will exit, otherwise it will keep on repeating again and again and keep on jumping over here loop 1, and this whole loop will be keep on repeating until the value of the R19 becomes 0. So let's debug it. So as you can see in R16 and R18, in R16 00 is being stored, and in R18 0xFF is being stored. Now the port D will be declared as an output port. Let me show you over here. as you can see, the ddrd has been declared, the whole port has been declared as an output. Now the next command is, now we have initializing the value to the register 19. Over here you can see that the 25, I mean the 37 in decimal system is being stored in the register 19, or 0x25 in hexadecimal system. Now we have entered in the loop. Over there we are just decrementing the value of the register 19. Now as you will see, it will execute the take command, the value of the register 19 will decrease. As you can see over here, it was first 0x25, now it's 0x24. Now after that it will declare the output of the value of the register 16 on the port D, as you can see over here, which means our first LED will be on over here. Now it will add the value of the register 18 in the register 16 and save that value in the register 16. After that it will check if our status register of the 0 in the status register is 1 or 0. If it's 1, then our loop, it will jump back towards to the loop 1. If it gets 0, then the program will exit. Now I will show you that. Now as you can see, I am executing this, the LEDs are getting on and off, on and off, and as I keep on repeating it, it keeps on jumping on the register 9 from to the loop 1 and keep on executing these 4 commands, and the value of the register 19 keep on decreasing as much as I repeat it. As you can see, now the value of the register 19 is 01E. Now it will keep on changing until it gets 0. So over here I will just stop debugging, and now let's move towards our task 4. Now the task 4 is to take two values from the two different ports, and we will compare them and show it on the third port if they are equal or not. If they will be equal, then this value will be displayed on the port, otherwise this value will be displayed on the port. So let me show you the Proteus simulations first. So the two Atmel simulation, I mean task 4, I will just open the main and I will just copy this whole code that I have written, and I will paste it over here, and now I will start debugging. So and I will explain you the code. So now over here, as you can see, I am initializing the 3 register and storing values in them. Okay, and now I'm declaring the 3 ports as an output port. So let me select all the 3 ports from this input output window. Now in the next 2 lines, I am just reading the contents from the port B and the port C of the register, the values of the register 19 and the 20, and then now I'm comparing the register 19 and 20, because we have been told that if the value that is being compared on the register is this, then display a specific value on that port. If it's not equal, then display the other value on the specific port. So brneq done is equal to jump to the next command if our 0 register is 0, then it will jump into this loop and will keep on executing this command. Okay, if our values, compared values, will be same, but if they will not be same, then it will jump towards this line and keep on repeating it. So let me show you how it works. So as you can see, I have simulate the first 3 lines, and the register 19, 20 and 21, the value is being stored on the ham that I have initialized in the program, and now the output is being declared on the ports, as you can see over here. Now the input is being read from the 2 ports. As you can see, now the value is being compared, which is being compared internally. Now the values that I have stored in the register and 19 is same. As you can see, it's 0 0, so it will just jump towards the done. If it was not same, then it would have jumped towards the no loop and would have keep on repeating these 2 commands. Now it will just repeat these 2 commands, and now I will just stop debugging over here, and I will move towards our activity 5. Now our activity 5 is the implement following commands and just comments about their function. So let me open my left task 5 over there, I will just show you these commands and their function. I have already commented it, so it will be easy for you all to read it. So as you can see, this is our task 5. Now LDI command is used to initialize the value in the register 16. Okay, any specific value that user want to store in them. Now out is used to declare the ports as an output. Okay, now over here we are just declaring DDRB port as an port B as an output port, and the pin B port as an output port too. Sorry about that. Now subtract command is actually used to subtract two registers. The values which is being stored or which is stored in those two registers, that will be subtracted, and the value and the result will be stored in the register that is written first near to the sub command. Now INC is used to increment in the value of the register 18, and the DEC is used to decrement the value of register 16, 18. And now MOV command is actually used to copying the contents of the register 18 into the register 16. What it will do, actually it will copy the value of the register 18 and it will store in the register 16. Now STS command is used to store data, and now I'm storing this value in the register 18. And com command is actually the complement, which will complement the value of the register 18. And this is just the jump. Here is used to jump the execution line to the loop where we have declared this. Jump here means that this will jump over here. As I have written it over here, so it will jump here. So let me just cut it and write it over here. So now when I will execute it, when it will execute this line, and it will jump over here instead of ending the program. So now let's copy it and paste it over here, and let's cross it. And now let's just debug. Now as you can see, it's debugging, and as I executes the lines one by one, or the commands that I have written on the lines, you can see the output now, and you can see the values of the R16, R17 and R18 over here on the registers window, where all the registers are being used that we can use. Their range is from 0 to 31, so total 32 register can be used to store data. And now I'm subtracting R17 and 18, and now first you see that the value of the R17 was 0xFF, and the value of the R18 was 0x19. So when I subtracted them, the value was stored into the R17. So the value of the R17 will not be now 0xFF, it will be 0xEX. Okay, now I am incrementing the register 18, so the value is increased in the register 18. As you can see, it becomes 01. And now I am decrementing the value of the register 18, so it will be decremented. As you can see, it became 0x19. Now I am just comparing the values of now I'm just copying the value of the register 18 and storing in register 16. Now you will see that the value of the register 16 is as same as the register 18, because I just copied the value of the register 18 and stored it into the R16. That's what move command do. And STS is used to store the value in the register 18. Now the value of the register 18 will be changed. As you can see that the value of the register 18 is being changed. Now I will just complement the value of the register 18 over here. You can see it became 0xEX. Now jump here is you will jump this line over here, and then it will again run this program. As you can see, when I press to execute the next line, it just jumped over here, because jump command is used to jump or program pointer from one line to a specific line that we want to execute first. Com is used for the complement. STS is used to store data in the register. MOV command is used for copying the value of one register into another register. DEC is used for the decrement. INC is used for the increment the value of the register. Subtraction sub command is used for the subtraction of the two register. And you already know the LDI and out command, why are they used. So let me cross it first. I want to stop debugging, and sorry about that. Now I will just open the Proteus. Now There is a little bit problem with my Proteus. I don't know what's wrong with it, but whenever I upload a code and simulate it, it just get crack, or you can say it just break. Like the Proteus simulation fails, even my code is all right. I don't know what's wrong with it. I tried to search that error, but I couldn't find a solution. So let me show you. But some simulation is working. So over here we will just go to microlab, lab simulation, labs to Atmel codes. No, I want to simulate the task 2 first, so I will just upload the hex file of the task 2. And now as you can see, I try to simulate it. Simulate for a little. Oh, it's simulating actually. So now you can see, as our activity 2 was uh, to use these commands, okay, and to take input from one port and to display it on another port. Okay, now over here as you can see that I'm taking an input from the port B, okay, and I'm displaying it on the DDR or on the port for D, okay. So that's why it's just 00. Now I will just stop simulating this task, and I will show you the lab task 3, which was to turn on the LEDs. So I will just upload the hex file of that task. Okay, now as you can see, it's already uploaded. Now the LEDs are on in the sequence. Now I don't know why my LEDs are not turning off, since this is getting red, so it means the LEDs should get off. I know the reason why they are not get turning off. Actually, I haven't given any time delay, so the LEDs are just getting off for a very short interval of time, like for just few millisecond, or you can say 1 millisecond. It's such that we cannot just see it, but the LEDs are being closed. As you can see over here, this red line means that they are getting high, blue means that they are getting off. So I will just stop the simulations. I will cross it. Now I will show you the task for simulation. I hope it will work too, because last time it wasn't working. So let's just, it was the comparing activity, okay. So let's just try to, okay, let's open the lab task 4 again. And let's upload our hex file in it. Now I will just simulate it. Now you can see that this simulation is not working. It will just give some opcode error, and I don't know how to resolve it. I did search on internet, sir, but there was no solution on it. So I guess that there is some bug in my Proteus, due to which this simulation is not working. But I did write the code, and it was tried. As you have saw the simulation on the Atmel Studio, it is working on the Atmel Studio, but it's not working on the Proteus due to some bug in my Proteus, because it's an 8.10 variant of the Proteus and it's not too much stable. So now what, I will just start the recording of our lab 3. Okay, there were few tasks of the lab 3. I will just close this segment. So now let's move towards the activity 1 of the handout 1 of the lab 3. This is the Proteus, okay, and let me open the code to lab 3 Atmel code of the task 1. Yeah, So this is the task one of the lab 3. Now I will just open the tasks of the lab 3, which was the actually, let's refresh it first. Let's turn on the Wi-Fi. So our first activity was to write a code and take input from port B and to check if the number is odd or not. If it's odd, then blink the LED on the port C, or if it's even, then they should the LEDs should turn on in a sequence. So let me upload the hex file. Okay, so in F fifth semester. Simulation task one, not ELF file, hex file. Okay, now let me explain you the code first. So in this code, actually we are just writing the code and controlling our microcontroller by using the C language. Actually the include, these are the libraries that we are including. This is the area library and this is the delay library, because I am using delay in this program. So first I'm just declaring the 3 ports of my AVR or microcontroller as an output port. After that I have made an array of the char and I'm storing values in it. Okay, and then after that I'm displaying those values on the 7 segment display, and in the for loop it will just keep on reading these values and will display it on the 7 segment, and that port output is being taken from the port D and B, and the value of the array, like if over here the first, it will be the 0 on the 0 index of the array, the value is 0x3f, which is the hexa value of the 1. Now the 1 will display after the delay of the 1000 millisecond, or you can say 1 millisecond, the next value will be displayed, and so on. So let's open the first task, and this is the code of the first task. Actually I think I have explained you the wrong code, so let me explain you this one. Oh, that was the code of the 7 segment of the handout to task 1, I guess. So similarly over here I'm just including the libraries first, and after that in the main body of the loop I have just write a while loop which will keep on running this program forever. Now I'm declaring port B as an input port and port C as an output port, because we have to take input from port B and we have to display the values through the port C. Now after that I have just created a variable of the char type Z, and I have assigned the value of the Z, the value of whatever comes on the pin B, it will be assigned to the Z. Now I'm just checking that if whether my number is even or not. For that I have just taken its modulus with the 2 and have checked if it's equal to 0 or not. If it's equal to 0, then it will display the value 0b even over there, otherwise it will display the odd value. Okay, after that there is a delay of few seconds and then it will keep on running again. But if our value is not even or odd, then it will just, if our value is even, then it will just run this part of the program, and then on the port C it's 0x00, and that's our program. Now I will just run the simulation of the Proteus so you will have an idea. So as you can see that the value is actually even, so the alternate LEDs are being on. So if the I will change the value to the odd, now you can see the LEDs are turning on from LSB to the MSB. Okay, so was the task one of the lab handout one. Now moving towards the task 2, this code is actually what I have explained you already over here, so you can see it. Write a code to monitor bit 5 of the port C and to check if it's high or low. So I will just open the Proteus of that file first. Activity 2. Now let's move towards our code. Okay, so this was the code of the lab 3 handout 1 task 2, which I have explained you, and I guess I didn't explain you the code of the task 1, so I will just open it and I will just explain you that. So this is the code. Okay, now over here, as you can see that our what we are doing is basically just including a library. Okay, and after that, in the main body of the loop, we are just declaring two ports as an input and output port respectively. Now we are comparing that if the value of on the pin C is equal to 0, 0, 1, 0, 0, 0, to check that fifth bit of the port C is high 0 or not. If it's high, then it will display 0x55 on the port B, otherwise it will display 0xAA on the port B as written in the manual in hexadecimal A, or 55 if the port C is high or not, the fifth bit of the port C. So we will just simulate it on the Proteus. So now as you can see, it's not high, so it's displaying 0xAA on the LEDs. Now if I will change it towards the high, it will turn on the alternative LEDs, because on binary the value of the 0x55 is 10101101. Okay, and the 0xAA is 0101010. Okay, that's why the LEDs are turning on in such sequence. Now we will move towards the handout 2 code. This is the handout task 2 codes. Now we have two activities. Let me open their Proteus first, and I will open their Atmel too. Just close this one. And I will open their Atmel code first. So because it takes some time to get open, and now I will move towards their Proteus. So this is the Proteus of the activity 1, in which we have to display the 7 segment. I'm opening the Atmel code right now. Now as you can see, this is the Atmel code, okay, which I've explained earlier. I thought that it was the handout 1 task 1 code, but I explained you the handout 2 task 1 code. Now I will just open the task 2 code of handout 2 too, so I will just explain you that. So the task 2 of our handout 2 was to interface an hex keypad and glow any LED. Okay, and I have to display that if whenever we press any button on the hex keypad, the LED turn on. So first of all, similarly, I'm just including the libraries, and this is used to, you can say this is the like used to communicate with our AVR, like that I'm usually setting their frequency. Now first of all, I have set the DDR pin 3, 4, 5, 6, 7 as an high, and then on the DDRC I have declared pin C as an high. Okay, so these are the output ports, like pin 3, of the port D, pin 4 of the port D, pin 5, pin 6, pin 7 of the port D are output ports, and pin 0 of the port C are output port. Now what I am doing in this code is actually checking that if bit set, like if I press any key on the hex keypad, its bit will be 1. So I am just checking that if our pin D of the port, pin 4 of the port E gets high, or the pin 5 or the pin 6 or the pin 7 of the port E, then turn on the LED, otherwise turn off the LED. So that it was the code. Now first I will just simulate the first simulation of 7 segment display. So wait a minute, this is the wrong simulation. I will just open the right one. Microlab simulation. So over here, as you can see, as I will run it, so you can see over here it is running over there up to the B. That was our 7 segment. And now I will move towards our task 2 simulation, which is to check if our hex keypad, if we press any button on the hex keypad, the LED is closed or not. So Proteus is taking a while. It will just open. So now it's open. Over here, as you can see, I have interface and a hex keypad with 80 mega 328p, and over here is the LED. So if I will press any button on the hex keypad, the LED will turn on. Look, if I press 7, it gets turned on. If I press 8, it gets turned on. If I press 4, it is getting turned on. If I press 0, it gets turned on too, because I have given the 5 voltage. So I have set the columns high, and I am taking input from the rows. So to interface that hex keypad, there is a way. Either you give high to the rows, or you give takes input from the column, or you give high on the columns and take input from the rows. So that's it for the labs 1 or labs 2 and labs 3. I will just, my name is Khwaja Muhammad Anisur Rahman. So today our task is to interface LCD and to interface hex keypad and display its value on the 7 segment counter. So first of all, we will interface the LCD while writing the code in the Atmel Studio for the LCD, and then doing the simulation on the Proteus. So I will just open my source code. So over here it is my code through which I am interfacing the LCD using 80 mega 328p. So first of all, as you can see, I have just included the libraries, and this is the libraries that is specifically used for LCD. So if I will not use this library, then I will not be able to display the values, or to write commands, or to work on my LCD through the AVR. It will not be possible. So that's why it is necessary to include this library. So here you can see it is the main body of the loop. Here I'm just initializing the LCD, and over here this file is just a forever loop which will keep on running these commands which are written in it. So first of all, I'm setting the cursor of the LCD. As we know that 16 by 2 LCD has 2 rows. Okay, so over here I'm just setting the cursor on the 0 row and on the 0 column. After that, I'm just displaying these letters on the LCD by using the command which is called LCD display. Okay, now when I will run this program, you know what will happen. This word, the which is highlighted right now, will be displayed on the screen LCD interfacing. After that, I just edit the delay so we can see the text that is being displayed on the LCD for a while. After that, I clear the screen of the LCD while using the LCD clear command. Now after that, I am again setting my cursor on the LCD and I am displaying my name on it. I gave the delay of 200 millisecond, and after that, now I am setting the cursor on the second row, okay, and the 0 column. So now what will happen, that the row which is under my name, over there my roll number will be displayed. So because we know that there are 2 rows, so in the first row there will be my name, and in the second row it will be my roll number, and after that I just give the delay and just clearing the LCD. So let's open the Proteus. Okay, here is the Proteus on which I'm interfacing the LCD. As you can see, I have already made the circuit. So this is 80 mega 328p. This is a potentiometer, and this is a power source, and this is just ground to provide ground to the LCD. Now what will I do is to first I will debug my program to check that if it's working properly. As you can see, it has been debugged, so it means my program is running. Now the hex file is already generated in the folder, so what will I do is double click on 80 mega 328p, and in program file I will just put the hex file of the lab of the code that I have written. Now after that I will press OK, and now I will just start this simulation. Now as you can see that LCD is on. Now it is telling us LCD interfacing. Now after some delay of 200 millisecond, it will write my name on it, which is Anis. So let's wait and see. As you can see, it's now writing my name. Now it will write my roll number on the second row, because I set a cursor at 01 means 0th column and the second row. So as you can see that my LCD is working properly and fine. So now our second lab task was to interface the hex keypad with the 80 mega 328p and displaying the values on the digital 7 segment counter. So as you can see, I have already attached the 7 segment counters, and over here it is 80 mega 328p, and this is our hex keypad. Now I will just open my code that I have written for the hex keypad interfacing, and for that I have to close this one. It may take a while, so just let's wait for a little bit. As you can see, now it's opening. So over here, as you can see, this is my task 2, which is to interface the hex keypad with the 80 mega 328p and displaying its value on the 7 segment counter. Okay, so first of all what I did is created a character array named database, and I have stored the values of the hex keypad. As we know that on hex keypad there are values from 0 to 9, and then multiply, minus, subtraction, addition, etc. So after that what I did is created a function. Basically what this function is, function header. This function is created over here, which is the parameter, as you can see over here right now. Basically what this function is doing is actually looking for the key that is being pressed on the hex keypad, and that value which is being pressed by the key is being assigned to the x, and after that there is some condition which is checking whether the value of x is equal to this value or not. If it is equal to this, then on the port D, the display the value which is on the 8th index of the array at the 0 column. So similarly, it's the second condition, it's the third and fourth, they are working just with the same logic just I explained for the first condition. Now let's see the main body of the loop. So I just initialize some variables. Okay, A is representing the rows of the array, okay, and B is representing the columns. As we know that 2D array is initialized by giving number of rows and number of columns. So as you can see in the main body of the loop, I set my port D as an output port because I am connecting my LCD with the port D, so it must be an output so I can display whatever I want to display on the LCD. After that I just initialize the hex keypad with the port D as an input. Now I am just uh, declaring port B as a half input and a half output. I will tell you why. Because on hex keypad we know that we have to give continuously an high signal and as an input signal, so that's why I have declared port B as a half input and half output. Now this is a while loop which will keep on running forever. Okay, similarly I have another while loop for it, because in this while loop I will be checking all the conditions, like which key, which row and which column key is being pressed on the hex keypad, and then that value will be assigned to the variable x, and then x will be checking the condition that if x is not equal to this value or equal to this, then display this value on the counter. So as you can see, I have assigned the port as a port B as 0xEF. Okay, now the value of x is equal to pin B. Now pin B, we know that the half pin B is taking input from the hex keypad. Now whatever key we pressed on the hex keypad, no matter what the row or column of that key is, okay, that value will be assigned to this variable x that I have created. Now what will happen, that this x will be compared with with the value that I am assigning on the port B. Now this will help us to look for the what value or the what number of the key is being pressed, and then it will help us to display that number or the value of the key on the counter 7 segment, sorry. So now over here I have just called the look function, which will look and compare the values of the x, as you can see over here, and will compare with the values of the array, because over here it will look for it, and if it finds the value of that x on any array, then it will display that value on the 7th segment. Similarly, the second condition is also like that. Now I have just assigned the different value on the port B, and then I am again just checking checking that if x is equal to this value or not, then you will have to look into the row 1. Then I have called the function which will keep on looking for the in the row 1 to check that if any key is being pressed or not. Similarly, then in the second condition I have assigned a different value to the port B, because we know that on hex keypad there are many different values, so that's why I have to keep on assigning the different values on the port B, and then I have to compare them to check that if that key is actually being pressed on the hex keypad, if it will matches with the value of the x, then that key which is being pressed or the number which is written on the key will be displayed on the 7th segment. So let's debug it first to check if it's working properly. As you can see, the code has been debugged, so it means it's working properly. So let's open its Proteus. Now what we will do is to double click on it and again load the hex file, as this is the hex file of the code that I have generated. Now what will I do is just start the simulation. As you can see that the code is being simulated. Now you will get an idea why did I set port B as a half input port and half output. As you know that in the hex keypad we have to continuously give the 4 row or the columns as a high input, and then we have as output, and then we have to take input from the rows or whether from the columns or vice versa. Similarly, then I have set the port D as a output port because I have connected the 7 segment with it. So now as you can see, if I will press 4, it will display 4 on the 7 segment. Now if I press 5 on the hex keypad, it will display 5 on the 7 segment. Now basically this value, whenever I press any key on the hex keypad, it looks for the row and the column number, like its column is 3 and row B, then it is B3. In the code as you can see that it checks that if port B value is equal to df's, look over here, it means that the D row, okay, and the f is the one column. So over there if any key is being pressed, that value will be assigned to the x. Then for that we will check and compare it, and if that value is present in our array in which I have stored the values in the 2D array, then it will display that value on the 7th segment. So these were the tasks of the lab 4. I hope you all understand it, and if there are any question and queries, you can ask me. My name is Anit. So today I will be telling you about how to display TCNT register value on LCD and how to display that whenever our timer overflow flag has been overflown. So as you can see over here on the Proteus screen, this is our LCD and this is our ATmega 328P, and this is potentiometer and power supply and ground. So now I will show you the code. So here is the code through which we will be displaying that when our timer has been overflown and when our registered TC and T value on the screen LCD. So first of all, I just made a function named void delay. After that, you can see this is the int main body of the program, in which I have just declared the initialize the LCD. Then I have declared the port B as an output port, because I have been taking output from the port B on the Proteus, as you have seen already. So after that, I have put the condition while, for which this will keep on running forever. It will never breaks, because I want to tell you that the value of that TCNT again and again, and how much time does it overflow. So over here I just declared the repeat after variable on the port, and after that I have called the delay function that I made. So it's simple LCD clear command, so it will display that timer have overflown after this display function will be executed. So in the delay function, you can see that I have just assigned the value 0 to TC and T. Okay, it's a timer 0 registered, timer 0 on which we are doing the code. So now I have declared TCCR0A as a normal mode of operation of the timer, and I will set TCCR0B as 1, so it will be a normal clock selector, no prescaler. So again I have just cleared the LCD, and now this command, actually this command will be printing the value of the TCNT register, the counting from 00 to 256 milliseconds. So after that I have just put the delay, so we can see actually the value of the TCNT on the LCD, and after that delay it will just check the condition. This condition is actually telling us that if our overflow flag has been set or not. If our overflow flag has been set, then these commands will be executed, which will tell us that our TOV0 flag has been overflown, and after that we will just set our clock to 0 no more, and then we will reset our over flag, and after that these two commands will be executed, which will tell us that our timer has been overflown. So let me debug it first. So it has been debugged, so it's mean it will be working properly. So now, as you can see that, now let's upload the hex file in it. Okay, this is the hex file. I have uploaded it. Now I will just simulate it and you will just see it. So as you can see that our timer has been overflown, so it's telling us no, the reason that there is no the reason that we couldn't see any value of the TCNT register on the LCD is because it was for such a small interval of time, like for just few milliseconds. That's why we couldn't display it on the LCD, but it has told us that the timer has been overflown one time and TOV overflown. So now I will tell you about our second task. Okay, let me cross it first. Okay. Now this is our program of the second code. Over here you can see that I have just included the library of the LCD, and then this is the library of an interrupter. Then I have declared some variables, because the second task was to make a digital clock on the by using timer and display it on LCD. So over here I have just make a function which will be displaying number on the LCD, and in LCD data write I have assigned 0, because I want to write on this LCD screen. That's why I have assigned it a value of the 0. Now after that I have put in a check. If a is equal to 0, then it will write on the LCD. Otherwise it will just divide it the number and convert it to the into hex number, and then it will display that last two numbers on the LCD. This command will display the last two numbers on the LCD. After that I have made an other function to initialize the timer. Over here I just initialize the timer 1 TCCR1 be which have been set into the CTC mode, because we know that in timer there are many types of mode, which is one is normal mode, then CTC mode, phase mode, PWM mode. So I'm using the CTC mode, and after that I have set the clock selector as a one mode with no pre-scaling. Okay, now after that I have made an other function to initialize the interrupt which will be telling us when the seconds have passed, the minutes and the hours. And after that you can see I have initialized one global variable, and then I have used an interrupt for the 1A register. After that, in the code you can see I have made a subroutine of the timer, and in it I am just checking that if our check is equal to 1000, then set our check to 0 and put a second plus plus. Basically, you know that 1 second is equal to 1000 milliseconds, so the time in our timer is of in milliseconds. So that's why I am checking that if our timer is equal to 1000 millisecond, then set or second increment or second, so it will make our second one. And over here I am just putting a check to look at that if our seconds are 60, then increase one increment in the minutes, because we know that 60 seconds is equal to 1 minute. And similarly I am checking over here minute and incrementing the minute. When our minute will be less than or equal to 59, then it will set or R1. And similarly I am incrementing or up to 24, because we know in one day there are 24 hours. So this is the main body of the function in which I have just called those function. You can see that over here I am just initializing the LCD, then I have initialized the clock. Tick tock is the command to initialize the clock on the LCD. Now I have given a delay of 1000 millisecond, basically 1 second. So we can see clearly that when 1 second is increasing on the screen. Now I again cleared the LCD screen and put a delay of 1 millisecond. Now I have called the function of the timer interrupt that I made above, and similarly I call the second function to initialize the timer one. After that I am just comparing the value. Okay, the value that will start our timer from 1 millisecond. Now this is the while condition which will keep on running these commands forever, and our time will keep on getting displayed on the LCD screen. Now let's first debug it first. Okay, as you can see it is debugged. Okay, so now we will go on the Proteus, and let's go to the PC. I will just put a hex file in it. Okay, this is the hex file. Now I will just open it, and okay, and I will just start simulation. Now over here you can see that this is our second, this is our minute, this is our hour. So now it's been 3 seconds, 4, 5, 6. Now similarly when it will be 60 seconds, it will set minute 1. So I will just stop here, and so these were the two tasks of our lab 5, and I have completed them fully. And if there are any queries, you can ask me freely, and you can ask me the question. So our lab 8 was actually analog to digital converter, and our task was to make a temperature sensor using Arduino. So I will show you the code over here. Assalamu alaikum, it's Anis 18095. So over here, first of all, I have just initialized the libraries, okay, and declare a function of the car TOINT, okay. And now what I'm doing is actually in the main body of the loop I have just declared two ports as an output port, port D and B, and then I am initializing the LCD. Then I have declared a variable. Then I have made an array of the then the I have initialized a variable Q, then DDRC port C as an input port, and then I am using analog to digital mux. Okay, it is used to set a channel. Okay, and I have selected a 5, okay, with an external capacitor at AFR pin, as you can see in the comments. Now over here, now ADCSRA is actually used to enable the a DC analog to digital conversion interrupt, okay, on the clock of the 128 frequency. 28 hertz will be the frequency of the clock. After that, in the while function, actually what I am doing is just starting the conversion, because we have to display the temperature on the LCD screen. So in order to check that which value is being received, if we are just doing some conversion to check that if the value is correct, and then we will display on the LCD. And now here is an end condition, okay, which will be waiting to check if our conversion is complete or not. And after that we will just clear that flag, and we will just move towards over here. Actually we are just setting the ADC analog to digital converter value, which is 9.3. After that I am just assigning that value to the q variable that I have declared, and then I am just displaying that data on the LCD. As you know, sir, you have to this switch case statement was written because our LCD was displaying some data which was not right. So it was displaying the number in the hexadecimal system, and now what we are doing is just we have write this function over where we have just write a bunch of numbers telling that if this number appears in hexa, you have to display this on the LCD. So I will just simulate it first to show you if it's working or not. So I have to go below 5. I don't know why it's not working right now, but it was working in the lab and I did showed you over there. I don't know why my LCD is not displaying data right now. Maybe there is some problem, but well, just let's move to the next lab. But I did show you in the lab, but it was working properly at that time, so I will just check later what's wrong with it. So let's move towards the lab 9. So over here it is our lab 9. I will just open its Proteus first and then move towards the code, and I will explain you there was only one task in the lab 9, and which was to blink an LEDs using PWM. I hope you do remember. Sorry about that. I am just having a little bit flu and cough and maybe a fever. So here is the code. I'm just including the interrupt library, input output library, and delay library. Then there is a duty cycle. Okay, and then there is a main body of the loop in which I have set the pin 6 of the port D as an high. Then I am just using the communication mode through which I will these register WGM WG00 in the register TCCR0. These are the bits which are used to set the communication mode, and TMASK is used to enable the register. Okay, now I'm just giving the duty cycle on which it will be operating, and this is the global variable for turning on the interrupts, and this is the register TCCR0B, which is used to set the clock frequency if we are using a normal clock or pre-scaling or upper edge trigger or lower edge triggering. So after that there is a while which will keep on running forever. It will not let the program exit, and it will just keep on adding 10 in the duty cycle and check if the duty cycle is from greater than 100 or not. If it will be greater than 100, then it will set it to 0, because we have to turn on LED and then increase its brightness slowly. So this thing will be actually controlling the brightness and will keep on increasing the brightness of the LCD. And this is similarly we are just calling the timer, okay, interrupt function. So here it is the Proteus simulations, and I will just move towards it, and after some time it will just start to turn on slowly. fifth semester. Now you can see it is turned on as high. Now I will just pause the simulation so you can see the brightness of the light decreasing. Look, the bright, now the light got dim and now it will be turned off. So as you can see, it turned off. Now it will turn on again. As you can see, after some delay, look, it got turned on, then it will got turned off again. So this is what our lab 9. The control the brightness of the LCD using PWM. I hope you all understood it, and if there are some questions or queries, you can tell it to me and ask me. Now we will move towards our lab 10. Now our lab 10 was actually lab 10, 11, 12 were actually the labs that we do on FPGA and on the Cyclone. So I have the pictures of and the screenshots of the simulations of the quarters. This is the lab 10 pictures. Now there were actually 6 exercises in that lab. I simulated the code and then showed you, and I have the block diagram and everything. I will just show you from here. No, this was the block diagram of the exercise when that was made when we were using the code that you gave us in the handout. Okay, and this was the input output waveforms, and this was the circuit built by the Quartz, okay, of the exercise 2 that was on the lab 10, and this was the input output, and this was the code that we simulated on it. Right now actually the Quartz is not working on my laptop. I don't know what's wrong, so I guess I'm just using screenshots and just telling you what we did. And this was the exercise 3 circuit diagram that was built after executing the code, and this was the waveform, okay, the input wave, and this was the code. As you can see over here, we just used a bitwise communication, okay, and this was the output waveform, and this was for the exercise 5. So now I will just show you the lab tasks 11 screenshots. Okay, these are the lab task 11 screenshots. Over here we have to use the different methods and to use the quarters of the module, and you have explained us the code later, and which was very simple to check the control how to control the bits using quarters or FPGAs. This was the circuit diagram built by the quarters of the lab 1, and sorry about that, this was the input and output wave, and this was the circuit diagram of the method 3 in which we have used a mux, and this is the code of the method 3, okay, that we executed on the quarters, and all the waveform and the circuit diagram was built and we just located it. And this is the waveform of the method 1, input waveform and output, and this is the code of the method 2, and this is the code of the method 1 that we simulated on the quarters, and this was the circuit diagram of the method 2 that was built, and this is the waveform that was being built, input output waves of the method 2. Okay, so now let me tell you which method did we use. This was the handout. Okay, now in lab 3, first we perform the arithmetic operations using quarters. As you can see, this is the code. Over here, what are we using? Actually just assigning a 3 and 0 to the two variables, and after that we have output variables C, D, E, F, G, and then A is equal to 12, B is equal to 3. Then we are just doing multiplication, storing that answer in the C, then the division answer in the variable D, addition answer in the E, F, subtraction answer in the variable F, and so on. Similarly, we use the logical gates to compare the values of the variable A and B using quartet. Similarly, like that, we have used in the other exercise, we use relational operators to check if our value is greater than or less than A or B or not. Then we use the equality operators to check that if our bit in the binary. As you can see over here, we are just checking if our equality operators to check that whether our logical equality evaluates to 0 or not. Over here we are just checking it double equal will operate and check that if our equality is equal to 0 or not. Similarly, over here as you can read, then the next line is inequality to evaluates the x, then the logical inequality to evaluates the 1, and so on. Bitwise operator and the reduction operator to reduce the value one by one, and then the shift operator will be the shifting the values. And over here this is the exercise 6, and then we perform this lab number 11, which was using multiplexer mugs, which have different type of method. Now the method of implementation were there were three. One was gate level implementation that I showed you first, and the block diagram, the code, and the input output wave. And the second method was the logical statement implementation that you can see over here. Okay, now after that what we do was the case statement implementation. Okay, and then we just simulate it on the quarters and the waveform were obtained. So now in lab 7 we perform task which was to follow the Verilog code using the 4-bit adder, and in the task 2 we use the unsigned 4-bit adder. And over here I have the screenshots. I am really sorry, but the quarters is not working well, otherwise I would have performed it and showed it to you. But in lab I did show it to you because I was using the laptop of my groupmate, and right now the quarter is not quite working well. This is the waveform that was obtained by the 4-bit adder. Okay, and this is the input output where this is the circuit diagram that was built when we run the code that you gave to us on the quarters and we located it. And then this is the waveform of the second task, and this was the 4-bit adder that we used by adding two adders in the and connected them. And that's all for now. Thank you so much for teaching us, and I hope you will you were the best.
Assalamu alaikum. My name is Anis. So, in my previous video, I actually forgot to explain the codes of the lab 11, 12, and 13. So, now I will be explaining the codes of the lab 11, 12, and 13. So, first of all, over here, it here is the code of the lab 11, as you can see over here. So, this is actually in lab 11 we implement many operators on the Quartus software, and we just checked how they work, and we just build their circuit diagram and the graphs of their output. So first of all, the task that we are performing on the Quartus is actually performing an arithmetic operation using programming language. So first of all, actually I have declared the variables, and then I have declared that I will be taking two variables as an input, and the rest of the variables will be output. So over here I have just assigned the value to the a is equal to 12 and b is equal to 3. Then after that, assign c is equal to, this means that the over here I'm assigning a value to the variable c which is equivalent to the a multiplication into b, which means that 3 into 12 is equal to c. Similarly, in the next line you can see that I am assigning d is equal to a divided by 3. So whatever the answer comes from dividing a by 3, that answer will be equivalent to the and will be stored in d. Similarly, in E, 12 plus addition will happen, and 12 plus 3, that answer will be stored in E. Similarly, in F, subtraction, and for G, as you can see, in G we are taking modulus. So after taking the modulus, whatever the value will come, it will be stored in G. So this is how we perform arithmetic operations in the lab 13. So the next task that we perform was actually logical operators. So basically logical operators are AND, OR, NOR, XOR. As you know that they have different circuits, and they have different equations and through which they work. Their working principle or criteria is entirely different from each other. Like AND gate is like a gate which is only true when both of the inputs applied on the AND gate are true. If one of the input is false, then the output of the AND gate will be false. Similarly, for OR gate, if one of any input is true, then the output will be true. And it is necessary for OR gate that if both of the output will be false or input will be false, then the output will be false. So similarly, first of all, I have just declared the variables. As you can see, after that I have declared that the three variables ABC will be the input ones and the DEFG will be the output ones. So while making a graph, as you know, I have shown you the graphs after the simulation in the screenshots while simulating it on the quarters. Those graphs will tell us that these variables are the output variables, so they will tell us the graph of the output values that are being obtained after running the program. So first of all, I have assigned the values to A, B and C over here, as you can see. So the second thing that I am doing is actually assigning that D is equal to A and gate and B. So it means that if A is 2 and B is 0, then the answer will be 0. And then in the next step I am assigning E is equal to A or B, which means that if A is 1 even the B is 0, then the answer will be 1. Similarly, I am assigning F is equal to not of A, which means that it will complement the value of the A, which means that if A is 1 it will make it to 0. Then I am assigning that A is equal to or of C, which means that if both of them are 1 then the answer will be 1. And similarly I am just taking a not of C. Okay, now I will move to the next code that we performed. The next code that we performed was actually related to the relational operators. Actually, we know that relational operators are the operators that are used to do a comparison to check if this value is higher than this or lower than this, if A is greater than this value or not, if the value of B is greater than A or not. So these are the relational operators which are used to drive any relation between two variables or more than two variables. So as you can see, first of all, I have declared the variables. Then as an input I declared the four variables, and then as output I have declared four variables too, and I have assigned the values to the input variables. As you can see over here I'm just performing the relational operators. As you can see in the first line, assign E is equal to A less than B, which means that if left A is less than the B, then it will give you the true value, which will be 1. And similarly in the second line, as you can see, if assign F is equal to A greater than B, which means that if A will be greater than B, then it will be evaluated to false. Since we know that A is actually less than B, so it will give us the false value, which will be 0. Similarly, over here we are checking that if the value of A is equal to or greater than C, which will be stored in G, as we know that the value of A is 2 and the value of C is 2. So the both values are equal, so it will give us the true answer, which will be 1. And similarly in the same thing is happen. So we write the end module at the end of the program to tell that this is all the program, the main body of the program has finished. So our software quarters will know that to which line number it has to execute. Now the second thing is the equality. Actually we know that equality is are used to assign the values. Okay, there are many types of equality: logical equality and logical inequality. Okay, so if one of the operand is shorter than the other, it expand with zeros unless most sufficient bit is unknown. So over here, first of all, I have declared the variables. As you can see, I'm declaring 6 variables as an input and 2 variables as output. Over here, as you can see, I have assigned value to each of the 6 variables. And in the next step, I'm actually just using different equalities and performing tasks and storing those values in the other variables which have been assigned as output. Over here, as you can see, g is equal to a, equal to b, which means that if the value of a is equal to the value of b, then it will evaluates to true, and if it's not equal, then it will give us 0. Sorry about that. And similarly for h, we are first taking the not and then checking if it's equal to the d or not the value of c, and it will be stored into the h. Basically it's an logical inequality. Okay, and similarly in the next line I am also again just performing the logical inequality, and then the other one is the case of equality, which is looking that if the value of d is equal to the value of e, which is not equal, so it will give us your answer. And similarly for the k. Now I will just move to the next operator, which is our bitwise operator. Okay, so in bitwise operator, actually what we do is to perform XOR or XNOR. It is actually a negotiation. Okay, bitwise operators are basically performed on the two operands. If any of the operand is shorter, it is bit extended to the left with 0. So what it does is actually if any operand whose values is shorter, so it will extend its bit by putting 0 at the end of that variable number. So similarly, as you can see over here, I have declared the my variables, and then I am initializing few variables as input and then as an output. Then I have assigned value to the input variables. Then I am just performing a simple task, which is assign d is equal to not of a, which is the bitwise negation. Okay, it means that if the value of the b a is equal to 1100, then it will change it to the 0011. Okay, similarly assign e is equal to a and c, which means that if any of the value is 0, the output will be 0. If both of the values are true, then the output will be 1, which means that the value of the a is actually 1100 and c is 0101. So it will give us 0001 0. Okay, and similarly for f, it's an or logical operator, so it will give us 1 if any of the value is 1, and will give us 0 if both of the inputs are 0. Similarly, I'm just performing the simple task. This is the bitwise operator. Actually it just changes the zeros into the 1 and ones into the zeros. It's a kind of negation, like a type of not gate, we can see in simpler words, but it's not actually a not gate. And then there is a reductions operator. Actually reductions operators are NAND, NOR, XOR, XNOR, etc. Okay, which takes the one bit by bit and performs on it. So as you can see, I have declared 6 variables over here, 3 variables as input, 3 as output. Okay, now I'm assigning the value to the 3 variables that I have declared as an input, and after that I'm performing a function on it, or performing some task on it. Okay, as you can see, assign d is equal to and a, which means that it will perform a bitwise operator and checks the value of the a variable. As you can see, a is equal to 111, so it will perform 1 and 1 and 1 and 1. If all the values are 1, then it will give us answer 1. If any of the value will be 0, then it will give us 0, because it's an AND gate being used. And similarly for or, if any of the values 1, it will give us 1. As you can see over here, it is 010101, so it will give 0 or 1, 1 or 0, 0 or 1, so it will give us 1. Similarly over here, I'm just evaluating the XOR gate. You know the logical equation of the XOR gate, so it's easy to implement. Nothing is difficult in it. So over here, actually now we are using the shift operators. Basically shift operators are used to shift the values either to the right side or to the left side. It depends upon what kind of shift operator are you are using. As you can see in this small program, we are using both type of shift operators. First we are shifting the value towards the left, and then we are shifting the values toward the right by 2 bits. So how it is done, we will know it. First I have declared the three variables: one variable as an input, two as an output, then I have assigned some value to the variable a, which is 1010. Then I am performing an operation on the variable a and assigning the output of that operation to the variable b. So basically over here what I am doing is actually shifting the value of the variable a to the left by 1 bit. So it means that this one over here will be shift towards the left and will become 0. This will become 1, this will become 0, and this will become 0 2. So it will be 0 1 0 0. Okay, so that's what happens in basically in shift operator. It basically shifts our value towards the left or towards the right. It depends upon the us whether we are using the left shift operator or the right shift operator. And similarly over here, this was our lab tasks. Okay, now I will just move to the next one, which was actually about multiplexer and implementation of multiplexer using different method. Actually there are three different methods through which we can implement a multiplexer. As we all know what a multiplexer is. Okay, so we will just move towards the course of method one is using gate level implementation, which means that we can implement a multiplexer using logical gates. Okay, which is quite interesting because multiplexer is a very useful thing and it helps us a lot. So over here, as you can see that first of all what we have done is actually